So this is our problem, an example of coefficient of variation. Problem said that using the coefficient of variation determine whether or not there is great variation among the price of certain similar commodities given than among the life in hours under test. So this is our values, that is given price in rupees and life in hours. So now here we calculate the coefficient of variation. For coefficient of variation, how to calculate? So coefficient of variation is equal to s upon x bar multiplied by 100. So here s is our standard deviation, x bar is our mean, and 100 for percentage. So this formula used for sample data, but when we use the coefficient of variation in population data, this is sigma divided by mu multiplied by 100. This is a population data. So a researcher also use the sample data because they do not use the population data. They only select the samples, then use the coefficient of variation for this. So samples, it's not when we calculate coefficient of variation from population data, it means your time wastage. So researcher also used the formula for sample data. So I also use this formula for sample data. This is coefficient of variation s upon x bar multiplied by 100. S is our standard deviation, x bar is our mean. So for calculation of mean, in my initial top videos, I have to calculated about the x bar, that is summation of xi divided by n. And how to calculate the standard deviation? For standard deviation, that is equal to, for this series of data, summation of xi divided by n, sum of xi square divided by n minus sum of xi divided by n whole square. So this is our standard deviation, and when we calculate this standard deviation and mean, put these values in this formula and get the result of coefficient of variation for both price in rupees and life in hours. When we calculate price in rupees, this is our xi, we put this formula, standard deviation of this. And when we calculate life in hours, the formula will change, that is summation of yi squared divided by n minus summation of yi divided by n whole square. Here we use y for life in hours, and we calculate y bar. For y bar, that is also summation of yi divided by n. So let's go for column. For required values, we will make the column for necessary calculation. This is our calculation table, price in rupees and life in hours. This is our x and this is our y. X and y is given. So we need two columns, that is x square and y square. For x square, 8 at the 64, 13 multiplied by 13, 169. 18 multiplied by 18, 324. 23 square, this is equal to 529, and 30 square, this is equal to 900. Now here y square, 13 square, 169. Here 13 0, it means 13 square and 0 square is 20. 15 square, 15 now, 225, and 0 square 20. For 18, here is as in 324, and 0 square 20. Now 25 square, so 25 is equal to 625, 20. Here 345 square, that is 11,000 1,19,000 and 25. Now we need the sum of all these columns, because these values used in the formula for mean of x and also mean of y. So calculate all these values, sum of these r values. That is, for x this is equal to 92, and for x square we calculate when this is equal to 1986. For y, the sum of y is 1055, and for y square 25325. Now here we calculate for now here two different sides. Here is calculation of price in rupees, and here for life in hours. So for price in rupees, for x bar is equal to summation of xi divided by n. What is the sum of x? That is 92. So 92 divided by how much items? 1 2 3 4 5 divided by 5. 92 divided by 5, this is equal to 18.4. For standard deviation is equal to under root summation of xi square upon n minus summation of xi upon n whole square. So put the values, that is s is equal to summation of xi square. Here is a summation of xi square, 1986. So put this value in the formula, 1986 divided by 5 minus sum of x 92 divided by 5 whole square. When calculate all these values, after the calculation standard deviation is equal to 7.66. This is our standard deviation, 7.66. So put this in a coefficient of variation, that is s upon x bar, that is multiplied by 100. So standard deviation is 7.66 divided by mean, that is 18.4 multiplied by 100. This is equal to 41.63%. This is our coefficient of variation. Now for another coefficient of variation for life in hours, that is summation of for y bar, that is equal to summation of y upon n, that is the sum of y, that is 1055 divided by n is our 5. So this is equal to 211. For standard deviation, summation of yi square. Here is a summation of yi square. What is it? 253325. 253325 divided by 5 minus summation of y whole square. Here is a 1055. 1055 divided by 5 whole square. After the calculation of standard deviation, we get the last result, that is SD, or we can say S, simply S, that is 78.38. So coefficient of variation is equal to S upon x bar multiplied by 100. That is equal to, what is standard deviation? This is our standard deviation S, 78.38 divided by x bar, x bar, or we can say here y bar. For y bar is 211 multiplied by 100. After all calculation, coefficient of variation, that is coefficient of variation, that is 37%, 7.15%. This is coefficient of variation for life in hour. Now here we can see the coefficient of variation for the price commodities x is higher than the for life in hours y. Hence the price of certain similar commodities are showing greater variation than the among the life in hour under this test. So this is our coefficient of variation. So I hope you will understand clearly. For next topic, don't miss to subscribe my YouTube channel and press the bell icon. Thank you.